Hey guys, welcome back. For lesson 3-2, we're going to discuss functions. We have a couple of goals right here. Determine whether a relations are a function. Evaluate functions in function notation for given values. Today's vocabulary, we have function and then of course function notation. What is a function? It's a relationship between an input and output. In a function, there's exactly one output for each input. This is a little confusing for each person, but what that means is one x value can only match one y value. The relation shown is a function because each element of the domain is paired with exactly one element of the range. So we actually have two of them here. We have a domain, -6, -3, 1, and 4. You'll notice nothing there repeats. Therefore, we don't really have a problem because they will all only pair with one value of the range, making it a function. On the graph over here, this one's a little bit more difficult, but we do have this vertical line test concept here. Vertical line test to see if a graph represents a function. How do we know if it's a function? Well, a relation is a function if it passes the vertical line test, meaning a vertical line intersects the graph no more than once. That's also a little confusing for some people. So let's say I draw vertical lines on this graph this way. And you'll see it only intersects once down here. And I draw another vertical line right here and intersects once. And again, it only intersects once. And I can even cut these in half and it intersects once. So each vertical line I draw only intersects once. And if it only touches that graph once through that vertical line, then it is a function. If it does intersect more than once, then it is not a function. So even though if I draw a line this way and I intersect only once here, as soon as I draw a line to the right of it, it intersects in two different locations. And if I look at the domains of those, I have a 1, 2 for the first ordered pair and a 1, looks like 4 for the second one. And by that definition above, this domain of 1 is matched with two different range values, meaning it's not a function. It also fails the vertical line test because the two dots line up vertically. Example 1. Identify function. Determine whether each relation is a function and explain. Well, if I look through the domain, I see no repeats of the domain, which means I'm probably okay as I go across. And you'll see there's only one line coming off each side. So for each element of the domain, there is only one element of the range. So this mapping represents a function. For part B, I'm looking through the domains again. And you'll notice that the number 2 here shows up twice. So the element 2 in the domain is paired with both 3 and -3. This relation is not a function. For part C, we look through our domain. Remember, domain are the numbers that are first, our x values. So we notice that there's a 4 here that repeats. That might be a problem. So the element 4 in the domain is paired with both 7 and 13 in the range. This relation is not a function. Go ahead and pause the video and attempt to check. Okay, for this one, they want to know again which of these relations are functions. So if we look down the domain values here, we're looking for something that repeats first, and that will kind of pull our attention in. Once we see something that repeats, we check the range values. If the range values are different, then it's not a function. If the range values are the same, then it is a function. Now, since nothing in my domain really repeats, I don't really have a problem here. So this is going to be a function. For number 2, you can see that the domain of 0 repeats twice, which is not really a problem, but when we look at the range values that it repeats with, the first one repeats with an 8 and the second one repeats with a -1, which means it's not a function. And again, if you were to put those 2 points on a graph, those 2 points would line up vertically, failing the vertical line test. For number 3, we're going to look at the domain values first before we make a determination. So we look at, okay, we got a -2 here. It repeats. Now I'll check the range values. So I got a range of 1. So the first two, -2 is paired with a 1. And the second -2 is paired with a -7. So since that domain value is paired with more than one y value, more than one range value, this one is also not a function. So it looks like choice 1 only, so answer here should be A. Example 2, we have 5 schools competing in a long jump portion of the track meet. The distance of the players with the best jump on each team are as follows. You can see them in the table too, or in the picture. Part A, they want us to make a table. They already put team number 1 in there, 20.6. So team number 2 is going to be over here at 21.5. Team number 3 is right here at 20.9. Team number 4 is over here at 19.4. And team number 5 is right here at 20.2. Part B, determine the domain and the range of the relation. So the domain is going to be the team number, so I'm going to list that in roster form. If you remember, roster form is supposed to be in numerical order from smallest to biggest. So I'm going to do the same thing for the range. Okay, so there are all of our jump distances in order. Part C, determine whether the relation is a function. For each element of the domain, which is 1 through 5, there is only one element of the range. So this relation is a function. Go ahead and pause the video and attempt the check. For this one, we're talking about height. So Bailey recorded the heights of 5 of her friends. The heights in inches are as follows. We got Hunter 62, Ling 66, Ella 65, Omar 66, and Alma 67. Find the domain and the range of the relation. Well, the domain is going to be the person. So we've got 1, 2, 3, 4, 5 people. And the range is going to be the heights that matches them. So we've got 1, 2, 3, 4, 5 heights. And the only one that appears to have that one is choice C here. Part B, is the relation a function? Explain your reasoning. Well, we only have one person, let's say Hunter. And Hunter matched the 62-inch height. And Hunter can't match more than one, so Hunter's only paired with 1. So no domain values are repeated, so we are okay here. So the answer would be yes. And since choices B through C are saying no, the answer has to be A. And for each element of the domain, there is only one element of the range. Example 3, equations as functions. So determine whether 6x plus 2y is equal to 14 is a function and explain. And they went ahead and gave us a graph over here. Anytime you're given a graph, you want to use the vertical line test. So all we do is draw a series of vertical lines. And usually we do this in our head. We don't have to do it on the graph itself. And you'll notice that no matter how many vertical lines I draw, as long as they don't overlap each other, these vertical lines only intersect the graph once, meaning it is a function. So the graph and the equation represent a function. Go ahead and pause the video and attempt the check. Okay, so the check is asking us which relations described in the chart represent a function. Select yes or no in each row. So the relation passes the vertical line test. Yep. That's the very definition there. An element of the domain is paired with only 2 elements of the range. Well, no, that's supposed to be one element of the range, so that's not a function. A vertical line passes through more than one point on the graph. Well, it's supposed to only pass through 1 point, so 1 to 1. So that one would not be a function. The domain represents each student in a class, while the range represents the age of the student. Well, each student only matches one age, so yes, that would be a function. The domain represents the number of a day in May, while the range represents a high temperature for that day. So let's say we look at May 5th, there can only be one high temperature for that day. And for May 6th, there can only be one high temperature. So this would have to be, yes, a function, 1 to 1. And the last one here says the relation in the form of y equals x squared plus b. What we're going to find out is these kinds of graphs, these are quadratics, they end up being graphs that look similar to this, where you have like a U-shaped graph. And if you can envision the vertical line test going across there, you can say, yes, that does pass the vertical line test. For this next portion, we're going to talk about functions. Okay, so equations that are functions can be written in a form called function notation. And function notation just looks like this, f of x. Function notation is a way of writing equations so that y is equal to f of x. So it's just replacing y with the expression f of x. But this value in here, which is x, is still our domain. So the left-hand side, even though it's representing y, it still shows what the domain or the input value was. And the other side then, of course, will show us what the y value or the range value should be. So f of x and y are interchangeable when we're talking about functions. For example 4, they want us to find function values. So we have a function up here, f of x, and it's defined with negative 2x plus 9. They want us to find each value. This right here is actually a combination of finding the value of the function plus 3 more. So when they say f of 4, what they mean is to put a 4 in place of x and then calculate your function. So we have negative 2 times 4, which is negative 8. Negative 8 plus 9, and that will give us positive 1. So f of 4 is equal to 1. But the problem they were giving us was f of 4 plus 3. So f of 4 plus 3 is simply going to be f of 4, which we know is 1 plus 3 more. So f of 4 plus 3 is equal to 4. The table over here, the graph over here, the steps that they showed was a little confusing as to what's going on. Okay, the next one is f of 5 minus f of 1. So what they're asking us to do is calculate the value of that function from above when x is 5, then calculate the function above when x is 1, and take the two answers that come out of it and subtract them. So f of 5 is really telling us to take the 5 and substitute it in place of x and calculate. And we can see here that this is going to be negative 10 plus 9. And then negative 10 plus 9 is negative 1. And then the f of 1, we're going to substitute a 1 in there. So that's going to be negative 2 times 1 plus 9. That's going to give us negative 2 plus 9. And negative 2 plus 9 is going to give us 7. And of course, they wanted us to subtract the two of them. So negative 1 minus 7 will give us negative 8. So the final answer here should be negative 8. So if we go back and substitute those values in, 5 here and 1 here, we should end up with negative 10 and negative 2. And then negative 10 plus 9 is negative 1 minus 7. Yes, that comes out to negative 8. So sometimes it's easier to come over here and do one entire value by itself, do the other entire value by itself, and then come back and do the calculation that was mentioned between the two of them. So go ahead and pause the video and attempt the check here. You may need a separate sheet of paper. Okay, for the first one, they want us to evaluate f of negative 4. So we're going to substitute negative 4 in for x. And the first one will give us negative 3 times negative 4, which is 12. 12 plus 2 equals 14. So f of negative 4 equals 14. For this next one, they want us to evaluate f of 5 and then take the value of that and add 8 to it. So f of 5 is going to equal negative 3 times 5 plus 2. And whatever this value comes out to, we're going to add 8 to it. So that will give us a negative 15 plus 2 on the interior. And then negative 15 plus 2 is going to give us negative 13, and we're going to add 8 more to it, and that will bring us down to negative 5. So that should be a negative 5 right there. Now for part C, we have to calculate the function's value at 3 and the function's value at 6, and then subtract the two values. So f of 3 would be negative 3 times 3 plus 2, and that's going to give us negative 9 plus 2, which is going to give us negative 7. So this value right here is negative 7. So f of 3 is negative 7. I got to subtract from that the value of f of 6. So I got to calculate f of 6. So f of 6 is going to be negative 3, and in place of x, we're going to put 6 plus 2. The first one's going to give me negative 18 plus 2 is going to give me negative 16. So f of 6 is negative, don't forget the negative sign, negative 16. And negative 7 minus a negative 16 is going to give us a positive 9. For this next example, they have this long quadratic in function form. And the first part is pretty easy. All they want us to do is evaluate h of 2. So all we're going to do is substitute 2 in place of x for each of these locations. So they've already got that set up for us nicely here. So we'll substitute those in. Don't forget to do the power first. So this is going to be 2 times 2, which is 4, and then 4 times negative 6, which will give us negative 24. And then 18 times 2 would give us 36. And then our last step is to add all these together, and that should give us 48. Okay, for part B, it's a little bit more difficult to try to tackle this whole problem at once. So I recommend evaluating h of 4, then evaluating h of 1, and then come back and subtract the two of them. So I'm going to do h of 4 on the side here. So h of 4 is going to equal negative 6 times 4 squared plus 18 times 4 plus 36. Don't forget, all we did was substitute both of these x's with a 4. So we've got to do the 4 squared first, which is 16. 16 times Negative 6 is going to give us a negative 96 plus, and then 4 times 18 is going to give us 72 plus 36. Add them all up, and you get positive 12. So I'm going to come back over here to our beginning and put a positive 12 in place of h of 4, because h of 4 is equal to 12. Input a 4 into the function, and it outputs a 12. So the ordered pair would be 4, 12 for that point. Now we're going to find the value of that function again, function h, at 1. So h of 1 equals negative 6 times 1 squared plus 18 times 1 plus 36. Don't forget to do the square first. 1 squared is 1. 1 times negative 6 is negative 6. Plus 18 times 1 is 18. Plus 36. And we add them all up. And we get 48. So we go back over here. We get h of 1 is 48. So 12 minus 48 is the final answer that we're looking for. And that should be, what does that come out to? 36? Negative 36? Negative 36. Part C, we're going to calculate h of 5 and then subtract 7 from it. So I'm going to do h of 5 off to the side here. So h of 5 is going to equal negative 6 times 5 squared plus 18 times 5 plus the 36 at the end. So don't forget to do the square part first. So 5 squared is 25. And 25 times negative 6 is negative 150. Plus 18 times 5, which gives us 90 plus 36. Add all that up and we get negative 24. So h of 5 is negative 24. So if we input 5 into the function, it outputs negative 24. Then, of course, we've got a minus 7 from it. So negative 24 minus 7 gives us a final answer of negative 31. Go ahead and pause the video and attempt to check for each of these letters. Okay, for this one, we're using function g, and here's the rule for function g, 2x squared minus 8x minus 10. Okay, for the first one, we're going to evaluate g of 2, and that will give us 2 times 2 squared minus 8 times 2 minus 10. Don't forget to do the square part first. So 2 squared is 4, 4 times 2 is 8. Negative 8 times 2 is going to give me a negative 16, and then minus 10. We add all those together and we get negative, it looks like negative 18. So negative 18. The next one, we're evaluating g of 5 and then adding 12 to it. So I'll add the 12 at the very end. So g of 5 equals 2 times 5 squared minus 8 times 5 minus 10. For this part, you do the square first. So 5 squared is 25 times 2 is 50. So we have 50. Negative 8 times 5 is negative 40. And then minus 10. So 50 minus 40 minus 10 is going to give me 0. And then, of course, I wanted to add the 12 at the end. Don't forget we had to add the 12 here. So the final answer here is just 12. For part C, we're doing g of 8 and then subtracting 18. So I'm going to do the value of g of 8 and then come back and subtract 18. So g of 8 equals 2 times 8 squared minus 8 times 8 minus 10. Don't forget to do the square first. So 8 squared is 64. 64 times 2 is 128. Negative 8 times 8 is negative 64 minus 10. Subtract all those and you get 54. And then if I subtract 18 from that, 54 minus 18 will give us 36. Okay, this last one is g of negative 3 minus g of 4. So I'm going to do them both at the same time or one right after the other, then come back and subtract them. So g of negative 3 is equal to 2 times negative 3 squared minus 8 times negative 3 minus 10. And don't forget to do the square first. So negative 3 squared is 9. 9 times 2 is 18. And negative 8 times negative 3 is positive 24 minus 10. Add and subtract those and you get, looks like 32. Let's evaluate g of 4. So g of 4 is going to be 2 times, so g of 4 is going to be 2 times 4 squared minus 8 times 4 minus 10. Don't forget to do the square here first. So 4 squared is 16. 16 times 2 is 32. Negative 8 times 4 is negative 32. And then minus 10. And you'll see that these zero out. Those are additive inverses. So I have a negative 10 left over. And remember, I'm supposed to subtract these. So what I have over here is a 32 minus a negative 10, which is really going to give me 30. That should be a 32 plus 10, which is 42. Okay, for example 6, interpret function values. So Mason works at the movie theater after school. The function g of x equals 9.25x represents the amount of money he makes before taxes. After each hour that he works, evaluate and interpret the function of each value. Okay, so for part A, we have g of 8. So that means we're going to substitute a 8 in for x. And what we get is 9.25 times 8, which is 74. So what does this 8 mean? Well, it means he worked 8 hours. And if he worked 8 hours, he will make $74. So that's what the different parts mean. So g of 14. So we're going to substitute a 14 in for x. And 9.25 times 14 is going to give us 129.5. So this means that if he worked 14 hours, that's what the 14 is, he will make $129.50. So we interpret that as money. So 27.5, we're going to substitute that in for x. 27.5 times 9.25, and that's going to give us 254.375. That means he's worked 27.5 hours. He will make how much before taxes? Well, it is money, so we have to round this, $254.38. Go ahead and pause the video and attempt the check here. For this check, we have pools. A swimming pool that holds 10,000 gallons of water is being filled at a rate of 600 gallons per hour. The function h of x equals 600x represents the amount of water in the pool after x hours. So part A, find h of 3.25. So h of 3.25 will equal 600 times 3.25, which should give us 1950. So part B, describe the meaning of h of 3.25 in the context of the situation. After 3.25 hours, the total amount of water in the pool will be 1950 gallons.